Southwest 212. Let's find out if these triangles are right or not. This is called the converse because you have a triangle and all the sides lengths are listed. It is pretty easy to check whether something is a right triangle or not. You use the Pythagorean theorem and see if it works out. These triangles are a horrible example of that because it is blatantly obvious which one is right and which one is not based on what the picture looks like. But sometimes the picture may be deceiving. So if you square the sides like it has here, it squared 9, it squared the 40, it's trying to see if does it really equal 41 squared. So there they get squared and they add them together, and look, when you add up the two sides squared, they do equal the hypotenuse squared. So this would be a right triangle, and this would be a proof for why it really is right. This one here, you can tell it's not a right triangle by what it looks like, but you never know. The side lengths or the picture might not be drawn to scale. So if you check the short sides, the two short sides squared and added together, 12 and 18 squared, you get 468. But when you do 24 squared, you get 576. Those are not the same. They need to be equal in order for it to be a right triangle. So that would be no. Sometimes you won't even have a picture. Sometimes you will just have side lengths given, like 28, 21, and 20. How do you know which one are the legs and which one are the hypotenuse? Well, the longest side is always the hypotenuse, so I know 28 is the hypotenuse if this really is a right triangle, and 21 and 20 are the legs. So I would square 21 and I would square 20 and add them together and see if they really do equal 28 squared. If they're equal, it's right. If they're not, it's not a right triangle. Same thing over here. You should be able to look and tell which side is the hypotenuse and which sides are the legs. If you're going to find the distance from points right here, I would just always use graph paper. Plot the points, draw a diagonal line, and make a right triangle, and use the Pythagorean theorem. Hopefully that helps you guys, and you're doing all right today. Good job, guys, working hard when I'm gone. See you soon. Over and out.